9.6, Solving right triangles. Essential question, when you know the lengths of the sides of a right triangle, how can you find the measures of the two acute angles? What we've been doing so far is finding ratios given an angle, and now we're going to be finding angles. We're going to be introduced to a new symbol that's going to help us find an angle. Determine which of the two acute angles has a cosine of 0.5. So here we have a ratio and we're trying to identify which angle has this. So let's go ahead and start. I'm going to find the cosine of A, and the cosine of A is adjacent over hypotenuse, and in this case the adjacent is root 3, the hypotenuse is 2, and this one is not equal to 0.5. Let's go to cosine of B. That's going to be the adjacent over the hypotenuse, and the adjacent is 1, the hypotenuse is 2, and this is equal to 0.5. So the answer to the question is it's angle B. Angle B is the one that has a cosine of 0.5. The inverse trig ratios are going to help us find the angles. So this is what you're used to see. The tangent of angle A is equal to some ratio, and the ratio can be in fraction form or can be in decimal form. This symbol right here is going to say the tan inverse of the ratio is equal to the angle. The tan inverse of the ratio is equal to the angle. And this will be true for inverse sine and inverse cosine. Let's go ahead and take a look at how to use it with a chart. Here is the ratio. We know the ratio. We'd like to find the angle. Here's the tangent column, and here's about 0.75. And the angle that it goes with is right here, 37. So we say that the measure of angle A is about 37 degrees. Now here we have to read the sine column, and right here is the ratio. And we're going to go backwards and find the angle. So we can say that the measure of angle B is about 60 degrees. So we're going through an undoing process, and this is called an inverse. Using the calculator, we're going to be able to recognize this inverse process. It's actually located right here. How do you access that? Well, the color of these letters are usually the color of the second button. And so you press the second button and then press the sine button, and it will access this inverse idea. And of course we have an inverse for all three. All right, so how does that look? Well, here's our ratio, and we're going to say that the measure of angle A is equal to tan inverse. This will tell the calculator to give us an angle, and I've done it right here, and the angle it's given is right here. We want to round to the nearest tenth of a degree, so that's approximately 36.9 degrees. Now, measure of angle B will be equal to sine inverse of the ratio, and this is the way you enter it in the calculator, and the calculator will give you the angle, and that angle will be 60.5 degrees. All right, we can do this again with a fraction form as well. So the sine of some angle is equal to 12/13. To find that angle, we're going to take sine inverse of 12/13. The calculator can take a fraction, and you can see this will be the answer. It'll be around 67.4 degrees. We're looking for a tangent of some angle whose ratio is 5/12. So to get that angle, we're going to take the tan inverse of 5/12, and I've done it over here in the calculator, and that's approximately 22.6 degrees. All right, your turn. Go ahead and see if you can use your calculator and arrive at these answers here. And I've used a calculator and I have it. So let me go ahead and write the answers. The measure of angle G is approximately 23.3 degrees. The measure of angle H is about 42.8 degrees. The measure of angle K is about 19.9 degrees. Okay, to solve a right triangle means to find all the unknown side lengths and angles. So to solve a right triangle, you either do the following: find two side lengths or one side length and the measure of an acute angle. Okay, so here's an example. I want to solve the right triangle. Now I notice that I have two legs. So I think what I'll do is I'll use angle B, and I have an opposite leg and I have an adjacent leg. So when I write so, ka, toa, I can see I'm going to be using tangent. So the tangent of B is equal to 2 over 3. So the measure of angle B will be equal to tan inverse of 2/3. And I've put this in my calculator, and that's going to be 33.7 degrees. So angle B is 33.7 degrees. That means the measure of angle A will be the complement. And so all I have to do is subtract from 90. 90 take away 33.7, and I'm going to get 56.3 degrees. Now the last thing is I have to find C, and I can use the Pythagorean theorem. 2 squared plus 3 squared is equal to C squared, or C is equal to root 2 squared plus 3 squared. And you can see I put that in my calculator, and so C is about 3.6. So I have found the remaining sides. I have found the two acute angles, and I have figured out the missing side right here. Okay, your turn. Go ahead and stop the screencast and see if you can find all of the missing angles and sides. And here are the answers. Okay, I want to solve the right triangle, which means I have to find the missing angle and the two missing sides. So I'm going to find the missing angle first. That's just subtracting from 90. So this is going to be 65 degrees, because those are complementary. And now that I have that, this is 65 degrees, I have a hypotenuse, so I can find either g or little h. So I think I'll work with angle G, because angle G works with side G here. So this is an opposite, and this is a hypotenuse. And when I write SOHCAHTOA, I can see TOA. I can see that I'm going to use sine. So sine of 65 is equal to G all over 13. And so G is approximately, all I have to do is multiply across the diagonal, 13 times sine of 65, and I get about 11.8. So this is about 11.8. Now, I can either use the Pythagorean theorem, or I could go ahead and use cosine. So I'll just use cosine. Cosine of 65 is equal to adjacent, so h is my adjacent, over hypotenuse 13. And so I just put this in my calculator, 13 cosine of 65, and I'm going to get approximately 5.5. So this is about 5.5. Okay, your turn. Stop the screencast and see what you can do. And here are all the answers. This is the end of the screencast.